All right, let's bang out 2 more problems in this part 2. You can't skip over this one, folks, because there are some things I haven't taught you that you're going to recognize here, namely dealing with the angle at the end and making sure it's in the right quadrant. All right, a force of 150 newtons at 60 degrees added to a force of 200 newtons at negative 40 degrees. So a quick drawing of that is going to look like, so we've got 60 degrees, and that's going to be 150 newtons. And then we also have negative 40 degrees, which is going to be below the x-axis, right? Because we know negative 40 goes counterclockwise. Or, hold on a second, nope, clockwise, right? We're going this direction. So that's going to be negative 40 degrees right there. And if you want, you could write 40 degrees here, but that's actually not that useful. What we really care about is the angle going in the typical positive direction. So if this is negative 40 degrees going this way, I want to know what this is going in that direction. And of course, that's going to be 360 minus that 40, which gives me 320 degrees. So instead of writing 40, which isn't super helpful here, we should instead write that this is 320 degrees. Okay. And what is the magnitude of this one? It looks like we've got a force of 200 newtons. Okay. Now, it's unclear where this is going to end up, what quadrant this is going to end up in. And, you know, part of me feels like maybe it's going to be below the x-axis because we've got 200 newtons going down. But to figure out what quadrant it is, we're going to look at our resulting x and y force components. So let's just go ahead and break this up into force 1 right here, and let's break this into force 2 right here. So the force 1 x component is going to be our force times cosine 60, right? I got my force from 150 and my angle from 60. And that's going to give me a value of 75. How nice and friendly. We'll have to put that somewhere else. F sub 1 y is going to be the same thing, except we're going to do sine of 60, and that's going to give me 129.9 newtons. Now for my F2, I'm going to go right down here. My F2 force, that's coming from this picture right here, the right one, I'm going to be at 200 newtons, and then we're going to have, let's see what else, cosine of 320 degrees, and then this is going to be 200 newtons times sine of 320. And those values give me 153.21 and a negative 128.557. Now let's talk a little bit about these answers, because it's going to help us understand how to do our angles and what sign it's going to be. This right here, we've got 75. That's essentially saying that this is 75 and that this is 129.9. And here, this is saying we are at a right, or an x value of 153.21, and then we're going down negative 128.557. Well, we still have to find our f sub x and our f sub y. So our f sub x, we're going to sum up all the x's, and so that's going to be adding up 75 and 153.2, and that's going to give us 228.21 newtons. So that's going to be equal to our f sub x. Okay, so that's really important there. Our f sub y is going to be adding up, that was not pretty, all the y values. So that's going to be the y value from the first force and the y value of the second. And that's going to give me 1.343 newtons, which is equal to f sub y. And so now is when we have to say to ourselves, what quadrant are we in for our angle? Because we've, we're already kind of saying, okay, we know what our x and y component is of the resulting force vector. So we think about it as this is going to be equal to, go back to red here, 228 in the red direction, so in the x direction, so that's 228.21 newtons. And then, oh my goodness, look at this. I thought it was going to be negative, but it actually ends up being slightly above the x-axis. Even though we had more newtons going south, it just wasn't enough angle to pull the resulting force vector to be negative or down. So this little thing right here is a 1.343 newtons. So if you were to graph this just like a coordinate, like an XY coordinate, you would see that we're in the first quadrant, and that's going to tell us that our angle, our direction's in the first quadrant. So it would be something like this, okay? Well, let's actually get our magnitude. Our magnitude's going to come from what? It's going to come from the Pythagorean theorem right there. So that's going to be our resulting force vector is going to be the square root of 228.21 squared plus 1.343 squared. And that resulting force vector gives me 228.2 newtons, which makes sense, right? Because this is pretty much nothing. So we know that our resulting force vector here is going to be 228.2 newtons. And I'm going to also box this off too, because that was kind of our final answer. Now our angle, we know it's going to be in the first quadrant, so all we have to do is theta equals tan inverse of my f sub y, which is 1.343. That's from right here, divided by my f sub x, which is 228.21 newtons. I don't need to write the n though. And we get theta is equal to, it should be a real small angle, and I do, I get 0.337 degrees. So I can't even fit that in there, but that theta would be basically right here. So you pretty much end up with a resulting force that is almost directly east, but not quite. So our final answer is going to be 228.2 newtons at 0.337 degrees. So you need both of these answers right here. Okay, let's try example 7. Now I could guarantee you that this one is going to be a little bit trickier to find the angle, even though we thought last one was too. All right, so here we go. We've got a force of 300 newtons west plus a force of 400 newtons south plus a force of 500 newtons at 30 degrees. So drawing that, you don't have to draw it if you don't want to. I like it just because I feel like I can check my answer with it, make sure the reasonableness makes sense. And then we've got 400 newtons south. That's going south. And then we've got 30 degrees with, what's our magnitude here? 500. So I just taken that from. So we're actually going to add 3 vectors right now, and which means we're going to have to do this 3 times with our f sub 1, f sub 2, and f sub 3. Not a huge deal. But first of all, this is 300 newtons at how many degrees? Well, that's going to be 180 degrees, because if you were thinking about where you're at on a unit circle, 180 degrees would absolutely be that angle right there. So this is going to be 180 degrees. If you're south, what would that angle look like? Oh, going kind of multiple colors here. Going south, well, you're starting here and then you're going down to this. That would be an angle of 270 degrees. So I'm going to write that here at 400 newtons at 270 degrees. And then here I've obviously got 500 newtons at 30 degrees. So let's go ahead and put this in. I need an f sub 1, I need an f sub 1 of y. All right, this is going to be 300 cosine of 180, which is going to be equal to something. And then I'm going to have 300 sine 180 equal to that. This one's going to be the second force, and it's going to be 400 cosine 270. And then this one's going to be the same exact thing, except we're talking about y now, and we're going to have to use cosine. So that's going to be 400 cosine 270. Just kidding. Why do I keep doing that? I deserve to have fired. Fire me. There we go. All right, and then the next one here is going to be f sub 3 of x, because we're at our third force. That's going to be 500 cosine 30. And then my f sub 3 of y is going to be 500 sine 30. All right, I did this before in my calculator, but if you want, you can pause and check, but make sure you're in degrees. I get minus 300 newtons, 0 newtons, which makes sense. Here I get 0 newtons, which makes sense because I'm not going left or right, but I am going down 400 newtons. And then here, it's going to be a little bit more mixed. Okay, and then this one is going to be 383 newtons. Okay, our next job is to find our F sub x and our F sub y. Those are our force components for our horizontal components. So F sub x, I'm not going to write that sum anymore. You now know it's summing up this, this, and this. And when I do that, I get 21.4 newtons. And then my F sub y, I'm going to add up 0, negative 400, and 383, which is going to give me a negative 17. At this point, if you have any value for your F sub x or F sub y that is negative, it is going to be a little trickier to find your angle. So if I were to draw this, basically what we have here is our F sub x is going to be 21.4. And then our y component is negative 17. So when I do my tan inverse and I get theta equals tan inverse, I'm going to keep everything positive because it's not going to be super helpful to have a negative in there. In fact, it might even confuse me. So I'm going to keep it positive as 17 over 21.4. And I get theta is equal to 38.46 degrees. But where is that 38.46? It's actually right here. And what I really want is this full angle to here, because that's where my resulting force vector is right there. So let me redraw that. My resulting force vector is right here, so I really want the angle that's this. So of course, to do that, we do what minus what? We're going to do 360 degrees minus that 38.46 degrees, and that's going to give me 321.536. And that's how I get that. Now I do want to show you kind of an optional way. You can keep the negative in there if you actually did tan inverse of negative 17 over 21.4. It would actually give you negative 38.46 degrees, which you can realize that that's right where my green angle is below the x-axis, and then you could do 360 minus a positive 38.46 degrees. So you're welcome to do that. That's totally fine. I mean, it doesn't matter to me which one you do. No big deal. Now you might have realized here that we have our direction, but we kind of missed out on our magnitude. And I'm going to get to that right now. That's just going to be coming from this formula right here. So that's going to be the square root of my f of x squared. So that's going to be 21.4 squared plus negative 17 squared. Doing that math in my calculator, I get 27.3 newtons. And I do want to add my final answer of at 321.536 degrees. That's our final answer right there. All right, folks, we're going to do a couple more problems like this, but they're going to be word problems on the next topic. It's going to be extremely similar topics, so if you feel like you need more practice with that angle not being in the first quadrant, you might want to watch the next video for the next assignment. It will help you certainly with these as well. All right, thanks, folks.